Okay, this is 6M11. These are some story problems. Okay. Got 4 examples and you're going to do 1 problem. That's it. Okay. Example 1. And you can read it from the document along with me. The ideal length of a certain length of nail is 20 millimeters. The actual length must be within 0.4 millimeters of the desired size. Write an inequality that describes a range of the acceptable lengths of the nail. Anytime I see the word range highlighted, I make a number line. I need a number in the middle and 2 numbers on the side. Okay. Now, the ideal amount or acceptable amount is the middle. Don't put 0 in the middle. Okay. You're going to put 20 mm. Then, to find the sides, you go 20 plus and 20 minus. And then 0.4 is the amount you're going to add, because you can go over it or under it. So 20 plus 0.4 is 20.4. That goes here. And then 19.6. That goes here. Now you got everything you need. Okay. Now range is in between them. You fill in the circles. Okay. Now you need to use a variable. Okay, you're talking length, so I would use L. Don't put 20 there. 20 is not going to be put on top of this. 19.6 on this side, and then the 20.4 on the other side. So we need to open it to the highest and then open it to the L. Okay. That's the answer. Okay, don't write this next thing down. So I'm going to pick a number in between. Let's pick 20.1. So it opens to the higher number here, and then by these two it opens to the higher number here, so everything checks out. Okay, this is the answer. Okay, example number 2. Sometimes these have 2 number lines you have to do. The ideal length of a horse fence is 300 feet. The length must be within 5 feet of the ideal amount. The ideal width is 450 feet. The width must be within 10 feet of the ideal amount. Write inequalities for the range of both the length and the width. So range, but you need 2 number lines because you have to do the length and the width. This is how range is set up. Okay, so the ideal length is 300 feet. Then 300 plus, 300 minus. Okay, within 5 feet, so 5, 5. So 300 plus 5 is 305. 300 minus 5 is 295. So you're going to fill it in. You're going to connect them. Just like that. Okay, pick a variable. Don't just put 300 there. The variable you're going to pick, this would be length, so that's L. So you're going to put 295 on one side of the L, 305 on the other. Okay. You open the sign to the 305, then you open the sign to the L, not the 295. You never open the sign towards the smallest number. Okay. So L can be in this range. Okay, now the other one, I keep reading. The ideal width is 450 feet. So 450 plus, 450 minus, and that's got to be within 10 feet. So the maximum 450 plus 10 would be 460, and then 440. And connect them. Now pick a different variable. It's width, so we should use W. So 440, 460, open to the 460, open to the W. Okay, and these are my 2 answers, both of them. Okay, really the math is kind of limited that you have to do. Example 3. A manufacturer is carrying metal into rectangles that are 20 inches long and 35.25 inches wide. Each metal's length and width must be within 0.25 inches of the desired size. Write inequalities, okay, that describe the acceptable range for the length and width. So again, inequalities means there's got to be 2 of them. We're not putting 0 in the middle, those. Alright, so it's got to be 20 inches long. So 20 plus, 20 is in the middle, and 20 minus. Okay, now each one has to be within 0.25. So I'm going to use 0.25 as the plus minus the variation on both of these. So 20 plus 0.25 is 20.25, and 20 minus 0.25 is 19.75. So 20.25, 19.75. Fill in the circles, and there you go. Okay. Now that was the length, so 19.75 and 20.25. So open the sign to the 20.25, then open the sign to the variable. Okay, now that's your length. Now your width on that example is supposed to be 35.25. Okay. But we add and then we subtract. Okay, so the amount we're going to add is 0.25. The amount we're going to subtract is 0.25. So it's going to be 35.5. And then when you minus, it's going to be 35 even. Okay, let's pick width. So 35 here, and then 35.5 here. So you open the sign to the maximum, then you open the sign to the W. Okay, we have a nice little inequality there. Compound inequality. Just trying to relate this stuff to real life. Okay. Example 4, last example, then I'll talk to you about the problem. The ideal circumference of a women's basketball is 28.75 inches. The actual circumference may vary from the ideal by at most 0.25 inches. Write an inequality that describes the range of the circumference of the basketball. Okay. I know that gets in a habit putting 0, but not on these ones. Okay. 28.75. Is there, and you notice how it says inequality, not inequalities. Okay, there's no S on inequalities, so just one number line does it. So 28.75, it's pretty easy to see what you're going to plus and minus. It's going to be 0.25. So when I plus, I get 29 whole. Then when I minus, I get 28.5. Okay. Connect them. Now you're talking about circumference. Let's use C. So I open it towards the 29, then I open the sign to the C. Okay. Now number 1, it says write inequalities, so there needs to be 2 number lines. Okay, one for the length, one for the width, and both length and width, the plus minus number is the same, 0.05.